If you haven't seen the video on the sine rule finding length, I'd perhaps recommend that you do that before you watch this video, which is showing you how to find angles using the sine rule. The sine rule is given to us in the yellow box. It's the same as the sine rule when we're trying to find the length, except all we've done, we've flipped the fractions so that what we are trying to find in this case, we're trying to find an angle, is in the numerator of the fraction. It just makes things much easier. In the example, we're trying to find angle x, and the side opposite that is the 8 centimeters. So the ratio or fraction we obtain is sine x over 8. Looking at the other information, we've got 57 degrees, and that's opposite the 9 centimeter length. So the ratio we get there is sine 57 divided by 9, and those two ratios are equal because that's what the sine rule is telling us. To leave sine x on its own, we multiply by 8, and then remember, when we're trying to find an angle, we have to press the shift sign button on our calculator. That's how we write it, as sine to the power of -1, which we call inverse sine. In order to obtain that, we press the shift button on our calculator, which is the top left hand side, shift sign, and then what's in the brackets. The easiest thing to do is actually to calculate what's in the brackets and then just press shift sign answer equals. Shift sign answer equals. And hopefully when you've done that, you've got 48.2 degrees. In example 2, different letters, but that doesn't matter because it's simply about the angle and the opposite side. So we're trying to find angle x. The side opposite x is the 8 centimeters, so the ratio is sine x over 8. And then 35 degrees, the side opposite 35 degrees is the 10 centimeters, so that's sine 35 divided by 10. In order to leave sine x on its own, we multiply both sides by 8. As I was saying on the previous example, I would calculate the answer to this sum now, and then when you've got the answer on the screen, you press shift sign answer, and hopefully it will come up with 27.3 degrees for you. Now, we're going to look at something called the ambiguous case, because in actual fact, when you are pressing your shift sign button, there are two possible answers. So if you press shift sign of 0.5, your calculator will give you 30 degrees. But in actual fact, the sine of 150 degrees is also 0.5. You can just press that on your calculator, press sine 150, and it will give you 0.5. So if the decimal or fraction you have, 0.5, needs to be converted into an angle, how do you know that the angle should be 30 degrees or 150 degrees? Well, you have to look at information given to you in the question. Sometimes it will tell you that the angle you're trying to find is obtuse, or the diagram itself will make it clear that the angle is obtuse. So, when we're using shift sign, we must be aware there are two possible answers. One of them that the calculator always gives is the acute answer, but the other is obtuse. And there's the example I talked about. Sine 30 and sine 150 are both 0.5, but when you, i.e. the inverse sine of 0.5 is 30 or 150, and that's because your calculator will give you the acute angle x. In order to find the obtuse angle x, you simply subtract x from 180 degrees. Remember, your calculator only gives the acute angle. Alright, so you have to look at information in the question to tell yourself, I need to subtract that angle from 180 degrees. So let's look at an example then. We can see in the example that x does look like it's more than 90 degrees. It looks like it's an obtuse angle. So x goes with the length 17, so that's sine x over 17. 35 is opposite the 10 centimetre side, so that's sine 35 over 10. Multiply both sides by 17. Once again, I would calculate what you have here and get the answer to all this on your screen, and then press Shift Sign Answer, and hopefully you get 77.182 degrees. But we've said that x is more than 90 degrees, so we subtract 77.182 from 180, and that gives us the answer we require. So to recap, using the sine rule, it's used when we have two sides and the angle not between those two sides, or two angles and one side. That's a more formal explanation, but in actual fact we would use the sine rule when we are given one angle and the opposite side. If we're trying to find a length, then we would use that version of the sine rule where the lengths here, A, B and C, are all in the numerator of the fraction. If we're trying to find the angle, then with the capital letters there, they're the angles, then we'd use this version where sine is in the numerator of the fraction. In terms of the diagram, remember that lowercase length A is opposite the angle A or the corner A, and we mark the corners in capital letters. Lowercase length B is opposite angle B, and lowercase side C is opposite angle C. And finally, if we're trying to find an angle and that angle is obtuse, our calculator will only give us an acute angle, so we subtract that angle from 180 degrees to give us the obtuse angle we require.